Hey developers, welcome to this hands-on tutorial where we'll build a Docker CLI tool using Rust. We'll create a command line application that can list containers, manage images, and handle Docker operations using the Docker API with clean, professional code. This is part of our Rust programming series where we dive deep into building real-world applications. If you haven't checked out our previous tutorials on Rust basics and async programming, you'll find a link to our course below. All right, folks, let's jump into building our Docker CLI.
So we are all set to create a project now. So I'm going to start by creating a new Rust project using the cargo new command. So I'm going to call the project as my Docker. Let's move to the my Docker directory and I'm going to open this in VS Code. So this will create a directory named my Docker with the default Rust project structure. So next up, let's add some of the dependencies that's required for a project. So open your TOML file and update it with the following dependencies. So first up, we have Bollard, which is a fully async Rust library for interacting with Docker API. So we'll see what async is and how asynchronous code works in the future modules. But for now, it's a Rust library that we're going to use to interact with the Docker on our system. We already know about Clap. Tokyo is again the asynchronous runtime that's powering Bollard and other async operations. And Futures util is essential utilities for working with asynchronous tasks and streams. So save the file and run the following command. We're going to run cargo build. Great. So the build is successful now. Now we'll structure the project to separate concerns and make the code base easier to manage. So we're going to have a main file, which is going to be the entry point of our application. I am going to create a file called CLI. And this file will contain the command line interface logic. I am also going to create a file called Docker. And this file is going to contain all our Docker API interactions. Similarly, you can also create a utils file if you want to create a file to contain all the helper functions. Right now, I don't think I need any. So let us update our main file to reflect the modular design. So I'm just going to import both of these modules. So mod CLI and mod Docker. That's it. Let's run cargo run again. And well, everything works fine. Now, if you remember, our goal is to create a structure where the command hierarchy looks like this. So for example, for listing containers, you want to write my Docker list containers, right? Where my Docker is your main command, list is a subcommand, and containers is a further subcommand. And notice that none of these are flags right now. They are all positional commands. We can pass a flag to our list containers command, but we'll see that later on. So first, let's go to a CLI file and create the command structure. So I'm going to quickly add some code and let's see what's happening. So I've imported the clap library. Then we have the derive parser, which we know is a macro from clap and it's used to generate the argument parser for CLI. The name of our command is my Docker and about it's a minimal Docker CLI in Rust. Then you have your CLI struct and command is basically the main command that you want to execute, which in our case can be list, it can be start, it can be stop, or it can be pull. So command again is an enum. And right now I have started with the list command. So the list command can again be of two types. Either it can be list containers or it can be list images. So for now, let's say I just want containers. And there you go. So now we have nested subcommands under our main list command and we're going to start with containers. So now that we have a little bit of structure defined, let's write the main function to parse the CLI input and execute the logic based on this command. So I'm going to head over to my main file now. And first, let's import the clap parser module. Once this is done, let's parse the CLI input. And we already know how to handle the commands. we use match for it. So we are saying arguments.command match it, and if it is of type list and it has a list command inside it, you match it, and if it's a list command, you print listing all containers. Let's also import what we want. Great. Now let's run our program. And as you can see, we got our help that it's a minimal Docker CLI in Rust. And you got some of the commands that you can use list to list resources. And where is all this information coming from? From these comments that we have added. We can also expand. So we can write list help. And this is going to give you that my Docker list is this command. And here's how you can use it. So you need to pass something else here. So either you can pass containers, which is going to list containers, or you can pass help, which we just did. So if you're going to pass list containers, it's going to give us the print statement, which is listing all containers. Now let us add a flag, which is going to list all the containers, including even the stopped ones. So for this, first you need to modify the list command over here that we have, this list command. So this is going to include an all flag. So instead of just this containers, I'm going to write all bool. So over here, I've added fields to containers now. So this argument over here specifies that flag can be used as -a, which is short, or all for long, and it's a Boolean value. So it automatically handles the presence and absence of the flag. If all is provided, the value is true. Otherwise, it's false. Now let's modify the logic in our main file to handle this flag now. So if it's a list command for containers, it's going to receive a value called all. And this is how we're going to receive it. I'm going to say all. If all, let's print something. It says listing all containers, else listing only running containers. Again, I'm going to say list help first. So it's telling you that you need to pass a command, and the command can be containers. So let's say list containers, and it prints listing running containers. So if you remember, all automatically handles the flag value. So if it's not present, it means it's false. But if I'm going to say help over here again, it tells you that either you use all to include stopped containers, or we used help, which was already there, right? So I'm going to say all, and now it prints listing all containers. Whereas if you do not pass the flag, you get listing running containers. Let's also try to use the short flag, which will be just -a, and well, that works too. So we've updated the CLI, we've built the project, we've run with all the flags, and we've also validated the help message. Now it's time to add some Docker functionality. So the first step would be to create a Docker client. And I'm going to use the library called Bullard for it. And here's the documentation. You can just search Bullard documentation and you can get this. So first, for creating the Docker client, this is the main interface. Unix, you can use HTTP defaults. There are many ways of doing it, but I'm going to be using the connect with Unix method, which connects using a Unix socket. So we pass the connection socket path, the timeout, and the client version. Now, the address or the path that you're passing here is your connection socket path. For example, it looks something like this. We then have the timeout value and the default API version that you'll be using to communicate with the server. The example code is written over here, but first we need to find the connection socket path. And to do that, you head to your terminal, and the command we're going to use is Docker context inspect. So make sure Docker desktop, if you're on your Mac or Linux, it's running. And then you run Docker context inspect. So I have Docker desktop running successfully. And now I'm going to run my command. And from over here, you're going to use the value, this one. So it tells me that this is my socket location. And this is what I'm going to use in my code. Now let's head over to a Docker file. And I'm going to add some code for creating my Docker client now. So let's see what we are doing. So I've created a struct called Docker client. And this struct is going to just have one value called Docker. And it's going to be of type Docker, which I've imported from the Bollard library. So Docker is the main interface for calling the Docker API. It is also a struct. Now we're going to implement some methods for Docker client. First up, we have the new method. In the new method, we are creating the Docker instance by using the connect with Unix function. So as you can see, connect with Unix function gives us a result. So if it is successful, it returns the Docker instance or it returns an error. So over here, I've passed the path of my Docker socket, the timeout, and the client version. I've also used the expect function over here. So this function panics if the value is an error and it does nothing, everything is fine. So just to handle the result enum, over here I've tried a new thing by using the expect function. And what it does is it simply returns you the Docker client instance. Let's go to our main function and I'm going to say Docker client equals to, and let's import this from, let's do let, and that's all. So everything is working fine. Now let's go to the next step, which is the first command of listing all containers. And the method I'm going to be using for listing all containers is present in the Bollard library already. So if you check the index over here, you can find list containers. And it also gives you some example code of how to use it. So it takes in the immutable self as a parameter. It takes in some options, which is again a wrapped option, and it returns a result. So arguments are an optional list container options struct, and it returns you a vector wrapped in a future. Well, lot of complexity as we can see here, but let's go one by one. So first up, I'm going to import the list container options thing over here. Great. So this is just a struct that we're going to use. So now what I'm going to do is I'm going to add a method called list containers for a Docker client. And well, this can look a bit intimidating, but let's destructure it one by one. I've also added a few necessary imports over here, and let's see what's happening. First up, this function is public because of the pub keyword, and it can be accessed outside the module. The function is asynchronous. Asynchronous means it can perform non-blocking IO operations. And right now, let's not fret about the async and the await keywords. We'll look into them in the asynchronous programming module, which is present later on in the course. So right now, let's just ignore this. Then we have ampersand self. It's a method on an instance of a struct. You then have your all, which is a parameter to indicate whether to include all containers or only running containers. Then, if the method is successful, you return a result. Let's look at the function body now. So list container options is a struct. It's provided by Docker Bollard library, and it's used to specify options for listing containers, right? So I'm going to pass this option, which is all. So it sets whether to include all containers or not. And then by saying default, we use the default implementation of list container options to fill other fields. So if you come here, you can see that this is how you can use it. So over here, I'm not using any filters. So you can use filters like health and the value should be unhealthy. But right now, I'm going to just use the all flag. Now, after we are done, I am going to use our self.docker instance, which refers to the Docker client over here from the Bollard library. and it provides us Docker related functionality. So we can use the list containers method of the Bolard library using self.docker. We pass options as parameters. We await it. So awaiting over here basically means we're waiting for this to complete. And if there are any errors, they will be propagated using the question mark operator. We then pass OK. So of course, we're returning a result. So it wraps the fetched list of container in OK and returns it to the caller. Now let's use this in our main function. So I'm going to remove all this if else code. So this snippet over here demonstrates how we can use the list containers method of a Docker client. So first we are printing that it's printing containers. Then we are calling Docker client.list containers. So list containers is an asynchronous function and you need to await every asynchronous function. So we're using match for it. And as we know, it returns us a result. So if it's an OK, you execute this. If it's an error, you execute this. So if it's a success, on success, it returns you a vector container summary. So now if you see this container summary struct, all of these fields are also wrapped in option. It means they can be either some value or it can be an error, right? Now to handle the error, either again, we can do a similar match thing or we can use unwrap, right? So unwrap or default will return the contained some value or a default value. Let's say an empty string if it's a string value or 0 if it's an integer. So we are saying for container and containers, you just create a string, you extract the ID, the name, the status, and you print all of them. And each container's details are printed in tab separated formats. Also, if there's any error, you're simply printing out the error. Now, one thing to notice over here is that await over here is throwing some error. So it's saying that it's used inside non-async function. Again, a very asynchronous programming related detail. But in simple terms, if you're using await, the function where await is should also be an async function. And you can also make your main function async by using the Tokyo runtime. I would recommend to not fret on it right now. We'll look into it in detail later on. Now let's do some testing. So first up, I am going to say help, and it tells you that you use the all flag to include all the stopped containers. So first, we need to set up our environment to do real testing, right? So come back to your terminal and we're going to pull some images now. So to do that, you use the docker pull command. So I'm going to pull Nginx and Alpine. And now that we have these images, I'm going to create a container from the Nginx image. And also I'm going to create a container from Alpine. So this is just going to run for 60 seconds and then it's going to exit. So you can use the docker ps command, which will return you all the containers. Now let's use our my docker to validate. So first up, I'm going to say cargo run list containers. And as you can see, it presents you both the containers, my Alpine and my Nginx, just like we created. And now that 60 seconds have passed, if you print list containers now, it's only going to give you the my Nginx container because my Alpine has exited now. So to see this, we can pass the all flag and now it will give you both the containers, even the stopped one. So you can also use the executable in the target folder to run the same commands and you'll get the same output. Later on, you can export this path to your environment variable. So you can simply write my docker list containers all and it will also run the same. So till now, we've implemented a very clean and a very extensible CLI to list Docker containers. So we built a command hierarchy, which is going to make it very simple for us now to add more commands. We also integrated Docker. We leveraged the Bolard library to fetch container details. And we have also added optional flags for flexibility. Next up, we'll see how we can list all images. Now, Let's extend our CLI to list all Docker images that are available on our system. And I'm again going to use Bollard for it. So we'll interact with the Docker API to retrieve and display image details. So I'm going to use the list images function over here. So it returns a list of images on the server. And again, there's some example code to help us. So first, let's begin by adding the images subcommand to the list command. So I'm going to add images, and this adds the support for the list images subcommand. So I'll say list images. Great. Now in our main function, we also need to add support for it. So we are going to add a match arm for the new images command in the list command handler. So over here, I've simply added a println saying printing images. So let's go ahead and see what is happening. So instead of saying list containers, I'm again going to ask for some help. And it's saying that you have two commands now. Either you can list containers or you can list images. So if I pass images, it prints us printing images from the main function over here. Great. Now let us make a change in our Docker file. So again, I'm going to add a function called list images, which is going to fetch all the image data that we're going to use. So to start with, I've added two imports. I have imported image summary and I have imported list image options struct. And I've also added a function called list images. And let's see what's happening here. So first up, again, we have a public asynchronous function and it returns a result enum. If it's some value, it's going to be a vector of image summary. So on success, it will return us this vector, and this vector will contain metadata about the Docker images. On failure, it returns us an error. Now let's see the options for listing images. So list image options is a struct, and using this struct, we're going to specify the parameters for a list images operation. Over here, I'm not adding much functionality. I just want to include all images, not like any tagged ones or something, just everything. And then you have default. So this fills in other fields of list image options with the default values, whatever are present. Now we're using the Docker client, which is a field in our Docker client struct. And we're calling the list images method, which is provided by Bollard. And we're passing the options to specify parameters for the list images query. I'm going to ignore await for now. I am storing these images in the images variable. Then I'm wrapping these images in OK and I'm returning it to the main function from where I'll be calling it next. So let's add this code as well. So I'm calling the list images function over here. And I'm again using pattern matching to handle the result. So if it's an OK, I am going over all the images and I'm printing the image information. If it's an error, I'm simply printing out the error message. Also, one thing to notice, in this vector, we do not have option as type. So we can simply write image.id. Whereas for container summary, these were options. And that's why we had to use unwrap or default. So let's go to a terminal and I'm going to say list images and it gives me all the images that are present on my system. Great. So we've successfully added the ability to list all the Docker images using the list images subcommand. So with this functionality, our CLI now supports querying and displaying both containers and images. Now, let's implement the functionality to start a specific Docker container using its name. As we discussed in the HLD of this project. So we'll again use the Bollard crate to interact with Docker API. And over here, you can search for start container function. It starts a container. And this is how you can use it. So you say docker.start container and you just pass the name of the container. So let's update the command structure first. So in my CLI, since we're done with all the list commands, the next is to add the start command. It's just going to take container name, which is going to be the string. And to add some comment for it, it's the container name. Great. Now let's add the start logic in our main file. So over here, this is where the list command ends. Yeah. So this is where I'm going to add. So for start command, I'm simply printing starting container and the container name. Let's try the help command. So it tells you have two commands. You have list, start, and help is something that we already used. Now let's say start and help again. So it says starting container help, but I actually wanted, yeah. So it tells you need to pass an argument called as the container name. Let's say I want to start XYZ container, and it's simply printing starting container XYZ now from our main function. Great. Now let's add the functionality in our Docker file. So I've added an import over here for start container options. And in my start container function, I'm simply calling the start container function on our self.docker instance. None, I'm passing none for the options, just the container name. Let's also make the changes in our main file. So we're calling start container, and if it's an okay, we're saying container started successfully, else we're saying error starting container. So first up, what I'm going to do is I'm going to list containers. So as you can see, my Nginx is running fine, but the container, my Alpine, is still not running. So to do that, I'm going to pass my Alpine, and it says starting container my Alpine. And now if we list containers, we can see that yes, my Alpine was started successfully. Also, let's see what happens if you try to start a container that does not exist. It tells you that there was an error. So the error is being printed again from the main function, error starting container. Docker responded with status code 404, which says that no such container. Great. So with the start command, our CLI can now start Docker containers by name. We added the start command. We use Bollard start container method to start containers. And we're also pretty informative messages. And we're also enabling proper error handling to make the command intuitive. Next up, let's implement the functionality to stop a specific Docker container using its name. So first, let's make the change in our CLI. I am going to add the stop command. It also takes a container name. We'll add the stop logic in our main function as well. So for now, it's just going to print stopping container. Let's implement the stop functionality in our Docker file. To stop the container, you can use the stop container function from the Bollard library. It simply takes in the container name and it stops the container. So just like how we've done till now, I am going to add a function called stop container. This is something that I'm going to import over here. So over here in the stop containers options struct, I'm passing the value of t as 30. If you go to the Bollard documentation, T is basically the number of seconds to wait before killing the container. So we wait for 30 seconds and then we kill the container. After that, I'm just simply calling the stop container function, passing it the container name and the options. Let's implement the functionality in our main function as well. The same match. Great. Now I am going to go over to my terminal. And first, let's do a help. So now we also have the stop command present. I'm going to say stop and I'm going to pass in help. So it tells you that you need to pass a container name. Now, first, let's list all the containers. We have a container running called my nginx. What I'm going to do is I'm going to stop this container. I'm going to say stop my nginx, and it stopped the container successfully. Next up, if you try to list containers, we see that my nginx was not listed this time. So we've successfully added the stop command to our CLI, allowing users to stop Docker containers by name. Also, what happens if you try to stop a container that does not exist? Again, you get the similar error message that no such container with status code 404. As of now, in our project, we've successfully implemented these 4 commands. That is to list containers, to list images, to start a container, and to stop a container. The last one is to pull an image. So we'll implement the functionality to pull Docker images from the registry using the Bollard crate. And this is going to enable users to fetch specific images by name. And we're going to use the create image function from the Bollard crate. It creates an image by either pulling it from a registry or importing it. And this is how you can use it. So you need to pass from image in the create image options, and simply the options and nothing else. So this is how you can use it. We're creating some options and we're passing it to the create image function. For the create image options, you need to pass the from image parameter. So from image is the name of the image that you want to pull. And this parameter should be only used when you're pulling an image. So let's go ahead and implement the functionality. So first, I am going to add this command to my CLI. So this will be called pull, and we're going to pass the image name. Let's add the pull logic in our Docker file now. So let's look at the function now. So first up, this function is again public. It's asynchronous. It accepts the image name of the Docker image to pull as a string slice, and it returns a result. So it returns OK on success, indicating no errors, and it returns an error on failure. We then have our pull image options. So create image options is a struct that's provided by Bollard, and we are passing the name of the image that we want to pull in the from image field. So this specifies the name of the image to pull, and rest we're using the default fields. Now, this line is where we're initiating the image to pull. So self.docker.create image, it initiates the image pull using the specified options. It also returns a stream of messages from the Docker daemon, which indicate the progress of the information. And the stream is mutable because it will be iterative. Okay, so create image is basically sending us a stream of images. Now let's see what's happening in this while loop. So this is iterating over the stream, extracting each message, and we'll see how each message is going to be printed when we call this function. The try next method, it retrieves the next item from the stream asynchronously. And just to use this try next function, we have imported the try stream next trait over here. Again, it's very asynchronous specific code, but you'll understand it once we go into the asynchronous module. As of now, you can simply see it as that create image is sending you a lot of messages, and we are printing each message using the println statement. Let's update our main file now. So we pass in the image name that we want to pull, and if it's pulled successfully, you write image pulled successfully. So let's use the help command first now. So I'm going to say help, and you can see that the pull command is available now. So we write pull and help again, and it tells you that you need to specify the name of the image that we want to pull. So you can specify any image. I'm going to use an image called Postgres. So we're going to say pull Postgres latest. And this is basically the stream of messages that we are receiving and we are printing in the Docker file. This snippet over here is responsible for printing all these lines. And then later on, you can see that the image was pulled successfully. Let's do list images to validate if this was true. And well, you can see that Postgres latest was installed successfully. So with the pull command, our CLI can now fetch Docker images from a registry. We added a pull command to the CLI. We used the create image method from the Bollard library to download images. And we also displayed real-time progress messages during the image download process. And well, this completes the core functionalities of our My Docker project, making it a powerful and a very user-friendly tool for Docker management.